But yeah, it really the root of this practice is the user shouldn't have to guess how to use it. It shouldn't be like dug in there, like how the heck do I use this? Even things like all right, welcome to the Bioinformatics Lab Podcast. I'm Kevin Libwit with Andrew Page. We're from Theogen, and today we're continuing on the conversation of public health pipeline best practices, third part of this series, because there's so many best practices, Andrew, that have emerged over the past couple of years. So let's continue on right into it. 10F, this is within the documentation best practices. This one being pipeline functionality. So has the function of this software or this particular pipeline as it pertains to public health bioinformatics been clearly articulated? Again, hopefully non-controversial in terms of a best practice, but in any way have you described what the pipeline you've written is meant to do for the world of public health pathogen genomics? Your take on that?
Yeah, okay, so you can go from the very basic, right, which is a bash script, which is a pipeline, and has it been clearly articulated? Probably not. If you are lucky, you might have some comments, and if you're very lucky, you might have a paper describing it, but it's not necessarily, what you need for production, public health. And yeah, that's a problem. So I've seen all through the spectrum. So you've got your bash script, then you might have a higher level, which is, someone's gone to a lot of trouble to build their own, roll their own workflow management system and with pipelines on top of that. And again, those are probably, they could be Perl scripts or bash scripts, and we've both probably encountered those. Probably every postdoc in every lab in the world has written one at some point. And then you have you go into the actual proper heavy duty pipeline systems. And so one that I really like, or I really enjoyed over the years, is Galaxy, where you could build these very nice workflows and pipelines and visually look at them, but you wouldn't necessarily know what they do unless you give a really descriptive name. But you could see kind of how the different components link together. But the actual devil was in the detail, where you'd have to drill down and see, well, what parameters are these and why are these and what did they expect? And that can be a bit more difficult. And then, of course, you have things like Terra. Like you've developed probably more Terra WDL and workflows than I have. So what's your take on that?
I love that you brought up Galaxy, and actually, especially with respect to the documentation and pipeline functionality, because when I was first getting into public health, one of the first workflows I adopted was CifSan SNP, and they made that available on the Galaxy world as well. And their documentation was amazing. It was one of the first that I saw really take advantage of even things like read the docs. And it was like, oh man, I knew what was happening at every level. I knew what was happening in terms of what the expected input was, what was happening at every analytical process. It was the first time maybe I saw something like lucid charts. I was like, oh, the pipeline functionality is so clear and explicit. And it allowed me to follow what's happening with the data. And I could look at what the intermediate files are, what I'm expecting as outputs and everything in between. So I would say even as I've matured in my practices, that seeded this specific habit of pipeline functionality and ensuring that that's communicated out. So big thanks to Errol Strain, Justin Payne, and all those folks. And now you're seeing, like, in our work on Terra, every time we have a pipeline that's out there, we also explicitly try to indicate what is the function of these resources and how it pertains to public health. With like Theoproc and everything, we put the lucid chart out there. We say, hey, this is meant for whole genome sequencing, bacterial data, and for characterization specifically, and everything else in between. So I've always thought that was a major part. And without indicating the pipeline functionality, it kind of takes a technical practitioner maybe to dive in under the hood and parse out exactly what's happening. But if you're able to just clearly articulate it, it eases the process and increases adoption pretty readily there.
Yeah. And actually, I think one organization that does it, or one collaborative effort that does it really well, is NF Core.
Yeah.
And they mandate that you have the workflows there and how everything fits together and what the inputs are, and it's all in a stand process. And I guess it sounds trivial, but just standardized documentation, it is just a godsend.
Yeah.
When you can just look at something or look at a few different things and you know what to expect, all these boxes are being ticked, you know how it's going in, how it's going out, how it's being processed. Because we make errors all the time as in bioinformatics, and it's so common to have fundamental methodological errors in bioinformatics pipelines, particularly if you are maybe a jack of all trades and you don't fully understand the nuances. And you come across it all the time, like I don't know, people filling in assemblies with reference bases, and these silly little things that you think, well, competition should know not to do that, but actually not everyone does, or know why you shouldn't do it. And I've encountered some of those, say, when it's quite far down the line. So people have gone and written papers having made these errors, and at least you can be intercepted at that point. And then, but what's worse is maybe people are making decisions based on flawed methods, and they just can't see them, and people can't, understand because the functionality it's buried so deep. So, um, yeah, NF Core, fantastic documentation, fantastic way of figuring out what the functionality is, and then actually that allows you to build things. You can put these pipelines together and chain them, or even encapsulate them. Um, and you're probably going to get a better overall result. It's going to be more maintainable as well, because that's a very, very important element. Maintaining a pipeline, because these things break, and containers get you most of the way there. At least you've got a snapshot in time. But if you want to, update the software even slightly, or update database, sometimes those containers need to be rebuilt, and sometimes they can break. So you do need that maintenance, and obviously staff B and whatnot do come into their own there. Because things are kept up to date.
One more thing I want to say on this that you mentioned before we move on to the next one is knowing what the author's intent was, and maybe you go in and you realize that there was an error in their methodology or something like that. Like they might even having someone articulate what they believe or how they see their intentional functionality is really helpful, because they maybe like you say that you're doing a consensus assembly. This is the tools I'm using, but you as the user, especially a technical practitioner, may be like, oh, wait a minute, you might actually be using this tool wrong. Let me make sure I communicate to this author. Hey, actually, that method that you're using for this assembly, you're erroneously adding reference genome into your consensus. You should look at this. So even if it's in the light of bringing to the surface what's the author's intent of the software is helpful, because it may be wrong, and I think we should all be striving for that, to shine a light on everything that's happening so that the community can find those potential bugs. But and then the next practice here, right in line with everything we're talking about with documentation, is 10G, documentation for local install and or remote access. So is there any kind of communication about how to actually install or access your pipeline so that the user can actually take advantage of it in the way that it's intended?
Yeah. So one thing I really like about Docker files is that it sets out from, you got this blank canvas, and it sets out how to actually go and set up the software, all the dependencies, and get it running. And so I love that when someone includes a Docker file in their GitHub repository, because you can, it's just a step-by-step guide, and it's nuance that gets missed in textual documentation. Um, so I've worked on a lot of academic quality software, and the first thing I will do if there's no Docker is actually go and try and build the software from scratch. Like it's often a challenge. I mean, it can be a car crash, like particularly if this software has only ever been run in by one person or in one institution, and you need to actually go and figure out all the little dependencies that maybe they hadn't thought about, because it's just installed on their computer by default, or maybe they have a special license, or maybe they use a very particular extra little configuration that they totally forgot about. And so that's what I will always do. I'll build a Docker file, and then you have those set of instructions, and it's always useful. I've never found it's useful at all. But yeah, it is. I recommend anyone to go and add that to their repository, but also have better ways of documenting, like better ways of installing stuff. So Conda is obviously the leading tool that people use these days for installing bioinformatics software, and if it's documented there, then essentially in code, then you don't need to worry about installation. It's trivial then.
Exactly that. I think we're speaking to, again, the maturation of the field over time. Whereas before, in the past, it was like, man, you'd be lucky if there was at least step by step, what do I do with a clean Ubuntu instance? What are the app gets I got to run? What are the, blast packages I need? If you're using something in Perl, what are the, what is that Perl module? Yeah, I remember always having to get BioPerl and always struggling to download that in. Yeah, all these types of things. But now all that is like sort of a memory of those crazy dependency wars in the past. Because now, if you're using containers, if you're using Conda, if you're using things like NF Core, there should be pretty clear instructions on how to actually access that and get things set up. So again, just an intent to articulate a best practice that hopefully is pretty relatively non-controversial, but does your pipeline come with some instructions on how someone can get that running in a reproducible way on their machine. And then the last practice in this document, again, hopefully non-controversial at all, but is there any example usage? How do people actually use this? What are the inputs? What are the flags? What are the even expected outputs with that example usage? But does the author include an example of how to use the pipeline itself?
Yeah, that is one of my pet peeves as well, where people don't include like a small little toy data set for even testing. It's not possible in all cases. But nowadays I do like to include like an example data directory, so at least you have some files in there. If someone copies and pastes the example command, they can just copy and paste it in and it'll work. And so then at least you can verify that, okay, the software is doing what is intended. If that's not there, then often I will look at the testing directory because people will include files in there for testing purposes, and try and use those then to see will it actually work as expected and what the actual real usage is. Because sometimes it can be quite obscure. You might have an optional parameter that is actually really mandatory, and then people can break the standard specifications, for how commands should be how you should parse commands, coming in and parameters and whatnot. People do all sorts of crazy, crazy stuff, like simple things like do they include a dash H or dash dash help? Very simple, often forgotten. And that should be your first protocol for figuring out how does this actually work.
Yeah, and I think that's actually a 10 simple rules from Torsten on like
Yeah,
making sure that there's a help statement in there too. But yeah, it really the root of this practice is the user shouldn't have to guess how to use it. It shouldn't be like dug in there like how the heck do I use this? Even things like there's different ways to input data. Is it, hey, do I direct it to a specific file? Do I create a file of file names? How in the world do I do this? And what are the specifications there? So just easing the barrier for access to your endpoint user and making removing as much ambiguity as possible. So again, hopefully in these last three that we spoke to on this call, all of which are pretty non-controversial. So there's some ones in there across the whole document itself where, we've already gotten some not pushback, but discussion. Again, ensuring that workflow managers, that's not a necessarily blanket adoption across the field yet, but I do feel, and the working group as well, feel like that's kind of the rung in the ladder now of a best practice in the field. But before we end, I don't know if you have any final thoughts on the document at large, best practices for public health pipelines in general.
I think people should actually read it if they're doing any kind of development like this because it's super, super useful. And it's the culmination of, like a lot of very intelligent people coming together who've, been in the trenches, know exactly what's going on. And, you're learning from their experience. So I'd say have a read of it. And, thank you very much to all the people who put this together from Phage. It's a fantastic consortium. And this is exactly the type of international collaborative effort that we need.
Absolutely. And then the last thing I can say to this is that this is really the first step of many that this sub-working group wants to continue on in promoting these kinds of best practices, the next of which is going to be some kind of system where the ease of assessment of other pipelines, so some kind of checklist, probably in the framework of JOSS, the Journal of Open Source Science, where you can readily submit a PR or something similar where maybe even a third-party reviewer looks at your software or your pipeline and says, hey, is this individual meeting these practices and how? And then there's some kind of then collection of pipelines for the public health community that have been sort of, hey, these adhere to these practices. So we'll end there. Thanks, everyone, and see you all in the next.